500 volts is applied across two parallel plates separated by 5 millimeter. What is the electric field? What force will be exerted on a 200 microcoulomb charge? And calculate the acceleration and final speed of the 0.2 grams charge as it moves from rest at one plate to the other plate. So we have two plates like this. And they are separated by 5 millimeter. E is going from positive to negative. We need to find out the electric field first. We know electric field equals to delta V over T, which is going to be 500 volts divided by D in terms of meters. So it's going to be 0.005. That is going to give me 100,000 or 10 to the power of 5 volt per meter, or you can say Newton per coulomb. Both of them are right. Now I need to find out the force, and from force I need to find out the acceleration. Force is going to be E times Q. Force is going to be on this charge. So that will be 10 to the power 5. Q is going to be 200 times 10 to the power of negative 6. That's going to give me 20 Newton. And then it says find out the acceleration. F equals to m times a. So a will be F over m. F is 20 Newton. And mass is 0.2 grams. I need to convert it to kilograms. So it's going to be 20,000 divided by 0.2. It's going to be 100,000 to 10 to the power 5 meter per second square. Let me check it with the calculator again. 100,000, yeah. Meters per second square. Now I need to find out the final velocity. That's gonna be, I'm gonna use this formula for kinematic. Vf squared equals to V naught squared plus 2 times A times D. Starts from rest, so this one is 0. Vf squared equals to 2AD. So Vf squared is going to be 2 times A, which is 100,000. D is 5 millimeter, which is 0.005. So that's going to be 2 times 10 to the power 5 times 0.005. That's going to be 1,000 meters per second. Vf is going to be square root of 1,000. Which is going to be 31.62 meters per second. That's going to be the final velocity.